In these four examples, we will look at some different types of sets. So in number one, we see that we have a union. And what a union does is it takes two sets and it becomes the set of both of those sets. So it's basically going to combine, and we're going to say that anything in here or anything in here is going to be a solution to our set. So when we go to graph this interval right here, negative infinity we know is going to be an arrow pointing here. So we're going to focus on the -4 first. That -4 has a bracket by it, and that means it's included. So it's going to be a filled in circle, and I'm going to label that with a -4. Now our next number that's going to come up is 3. So I'm going to count over. This would be -3, -2, -1, 0, 1, 2, 3 is going to go here. And again, that's a bracket, so it's equal to, I'm going to fill that circle in and label that as 3. Now from here, when I go to graph, I know that -4 to negative infinity is one of my sets based on this set right here in the interval notation. So I can draw my arrow going that way. Then in this set right here, this says that from 3 to positive infinity, and that graph would look like that. So again, the answers to these would be anything included on this side, anything included on this side. So when we look at number 2, we don't have two separate parts. So this is only going to show up as one segment on our number line. Now we're going to start with the first one, just like we did over here. We worked from left to right. We're going to work left to right here. So I start out with the -1. Again, that parenthesis means it's going to be an open circle on the number line. And I'm putting it here. That is going to represent -1. So if I count over, this would be 0, 1, 2, 3, 4, 5. And then at 5, it's a bracket, so that's going to be a filled in circle, labeled as 5. And then from here, negative infinity and positive infinity are never mentioned here. So we are not going to be graphing the outside of these. What this means is that all solutions from -1 up until and including 5 will work. So we end up putting a segment in between. So here, what works as an answer would be from -1, but not including -1, all the way until we get to 5 and including 5. Now the last thing we're going to do for numbers 1 and 2 is express using the inequality notation. So here we have two separate parts here connected by the union, and that's going to show up as an or statement down here. So we're going to describe this part first. This part is talking about the values that are less than or equal to -4. So we would write that as x is less than or equal to -4. Or we look at this side, and these are when values are equal to or greater than 3. So I write x is greater than or equal to 3. So again, this part matches up with this side, this part matches up with this side, and then the union is going to show up as an or statement when we're writing this as an inequality. And then for number 2, again, this doesn't have two separate parts the way that number 1 did, so we're just going to have one statement here. And it's going to start with -1, and then from -1, we can see that all the values for x have to be bigger than -1. So if I put x in the middle here, then x is greater than, bigger than -1. Then when I'm talking about 5, all the values for x have to be less than or equal to it. So that's why that side, you can see it says x is less than or equal to 5. Now technically, if you were writing these answers by hand, if you were to write x is greater than -1 and x is less than or equal to 5, I would give you full credit for that. But when you're working on these problems on Delta Math, the expectation is going to be for them to be written like we have in number 2. And now when we look at examples 3 and 4, for number 3, I have two separate parts. So again, I know that this is going to show up as two separate parts here. It's also going to show up as two separate parts when I write the inequality notation here, separated by the word or. So on this side, when I start by talking about 2, I am going to have an open circle since that's a parenthesis. So I can start with that open circle and write in the number 2. Then from there, this would be the number 3. This one right here is going to be the number 4. This one at 4 has a bracket by it. That means it's included or it's equal to. So I'm going to use a filled in circle at 4. Then from there at 2, it's going to go towards negative infinity, so I can go ahead and put that arrow in. And then at 4, that's approaching positive infinity, so I can put that arrow in there. Then for number 4, I'll start out with 8 this time, and that has a parenthesis by it, so that's going to be an open circle at 8. Then this would be 9. This right here would be 10. So at 10, it's also an open circle because it's a parenthesis. And again, these never talk about negative or positive infinity. So what happens is that the solutions from 8 to 10 are what would work. So I'm going to make a line segment in between. Then finally, for the inequality notation here for number 3, I'm going to say that I know I'm going to be dealing with x, values less than 2, and it's not going to have an equal sign here because, again, this is going to be less than 2. Or when I talk about this side of the number line, it's values that are greater than or equal to 4. So that's where I get x is greater than or equal to 4. And then over here, because there's only one segment here, I'm only going to have one statement down here. We start out with 8. The values for x have to be bigger than 8, but not equal to 8, and then smaller than 10. So we fill it in this way. We show that 8 is less than x and less than 10.